understand better the process by which ozone protects us from damaging solar radiation, we need to understand reactions from a molecular point of view. So we're going to look at a molecular model that is going to help us understand how atoms are connected within each molecule. So most of these, it's going to apply to a compound that have a nonmetal and a nonmetal. So why is this? Because this type of compounds, instead of donating electrons, they share electrons. Okay, and this is very important. So when we look at hydrogen in the periodic table, we're going to see that hydrogen has an atomic number of 1. So what does that mean? We practiced before that the atomic number will tell us the number of protons. So hydrogen has 1 proton, meaning it also has 1 electron. In order for hydrogen to be stable, it is going to need to have a full shell, a full layer of electrons. So 1 electron by itself makes hydrogen be highly reactive. That's why when we find it in nature, we find hydrogen bonded or combined with another hydrogen molecule, and its chemical formula is H2. That's the chemical formula for hydrogen gas. So how does this come to happen? So we're gonna start by looking at a model where we represent electrons as a dot. So we're gonna use the symbol, and then we're gonna use a dot to represent the electrons. So we're gonna use the symbol, and we're gonna use dots that represent electrons. This type of representation is called Lewis structures. And we use it for showing the type of interactions that there are in covalent bonds. And covalent bonds means share electrons, right? So it implies the share strength. So by sharing electrons, nonmetals and non-metal compounds become stable. And we're going to use these Lewis structures to show that type of stability. So to figure out how to draw these Lewis dot structures, we first need to understand what valence electrons are. When we look at the atomic number of sodium that has an atomic number of 11, we gather that it has 11 protons, which are, remember, are the positive charge of the atom, and then it has 11 electrons. Well, the truth is that not all these 11 electrons are the responsibles for any type of chemical reactions or chemical bonds that sodium can form. So how many, the question is, how many of those electrons are actually part of a chemical bond? Understanding this is it's a little more involved than what we're going to cover for this class. But what we're going to do is that I want you to look at the group numbers from group A of the periodic table, right? So all the ones that have label A. The group number tells the number of valence electrons. So my question to you now is, what group is sodium located in the periodic table? You're right. Sodium is in group 1 of the periodic table. So group 1A. What does that mean? It means that out of all the 11 electrons, only 1 electron is a valence electron. So sodium has 1 valence electron. Let's practice some of this.